Basically, in the beginning, it was E. coli processes. I worked on interleukin 2, beta interferon, and later also like subunit vaccines like meningococcus C.
Hey everyone, welcome to SwitchHubTV. It's your host Wei and John. Today on the show we have Paul Zuur. Paul is a bioprocess engineer with a wealth of experience in research and development, manufacturing, and in particular fermentation technology. Paul, welcome to the show. How are you?
How are you?
I am fine. Thank you very much. And thank you for inviting me.
Well, thanks for having you. Thanks for allowing us the time to interview you. So we just want to start off with how and why did you get into science?
Okay, it started, I guess, already on middle school. I always liked physics, chemistry, and and then I felt I have to continue in this, and I would like to work in a laboratory. So it started before having any experience. So I just started, actually, I don't have a typical job development like you had. I actually started working and then studying. And I started working in a QC lab in a like milk products factory. And it was a combined working and learning trajectory. And since that involved also shifts, I did that only like 9 months because I really hated the shifts. So then I stopped in that job, and a bit later in that year, I started working for also working and starting with evening education.
So that, if we can go back a bit, that first company that you worked at, you did QC testing for milk products. What sort of testing was that? Was that microbiology or chemistry?
Yeah, mainly composition, like fat, dry matter, like a QC testing of the, and like there was baby food made, also chocolate milk, so like also viscosity measurement. So the basic analysis.
So it was more chemistry based.
Right.
So yeah, so how did you end up getting into microbiology?
Well, then I started working at and also starting in the evening school. And the education system in the Netherlands is different. So you have a dedicated laboratory school, like a middle level and a high level. And at that time, it was even more different than now. So in the end, I did like a bachelor education, but at the time, it didn't even qualify for a bachelor degree. That was changed later. So I did the whole trajectory. I started actually like in media prep, like in a media kitchen. And before I had one class of microbiology, they asked me, we have a vacancy. Would you like to take this job? So I started in fermentation before having any microbiology class. So I learned it on the job, and then later on school also.
Yeah, so you started first in the I guess the dirty prep work, preparing media for the rest of the lab techs and production as well, or just mainly for laboratory testing?
Mainly for laboratory testing. I mean, later I worked also at other companies, but I guess we will get there later. But yeah, I started like with preparing the media, and then my first job was in fermentation. So then you also have to prepare the media on a bit bigger scale, do your shake flask culturing and then fermentations, prepare samples for analysis. So basically learned it on the job.
Yeah.
So Paul, what's the process of fermentation?
What type of process?
It's more like what's the process of fermentation?
Okay. Okay, the process of fermentation. Well, you start with a vial of microorganisms, of your production organism. And the first project I worked on was for enzymes, food enzymes, and also some detergent enzymes, like it was an amylase and proteases. That was my first experience in fermentation. So first you have a vial of your microorganism. You put that into a shake flask with growth medium, culturing medium. You let it grow, for example, overnight. You have some more bacteria, and you inoculate that in a fermenter with a larger quantity of broth containing all the nutrients for your microorganism. And it started growing, and mostly in an industry, you also have a fed batch. So you start with a batch culture until you have a reasonable amount of bacteria, and then you start to feed to get more biomass and product formed. So in the end, after some days or a week, you stop the fermentation, you have an amount of biomass, but also your enzymes are produced either intracellularly, but a lot are extracellularly. So then you separate at the end of the fermentation, the biomass from the broth, and depending on whether it's intracellular or extracellular, you continue with either the supernatant or the filtrate, depending on the DSP, or you take the biomass to further work up the product.
And Paul, in that process, are you able to, within one fermentation, like have produced a number of different enzymes during the one run? I'm assuming you're able to, right?
You mean several enzymes together?
Yeah, exactly.
In one production run. Yeah, well, mostly it is a mix of your the enzyme that you want to have and some other enzymes which are also made by the microorganisms. So in the end, you have to separate those enzymes. Yeah. But obviously, you try to control the process in such a way that the main enzyme is at a high level, at the highest concentration. Yeah, but mostly you have some other enzymes also made, yeah.
And I'm assuming as well, I might be wrong, but that you're using modified organisms that contain whatever the sequence for the enzyme you want to produce or something like that.
At the time I started, there was not even the GMO techniques. That started a bit later, after a few years. So at the moment I started, there was just the classical enzyme. So microorganisms were just screened, like taken out of nature, screened, or with classical mutagenesis altered to have higher expression of the wished enzymes. The GMO technique started a few years later, and even in the Netherlands, it was not allowed. So some of our colleagues went to the UK to do the GMO work and came back with the microorganisms.
So and they were allowed to carry them. They were allowed to carry them on a plane, but not allowed to produce them in the Netherlands.
Well, yeah, I guess I was not involved in that part of the work, but I guess they were not allowed yet to manipulate, but we were allowed to culture them in the lab under controlled conditions. Yeah, I mean that developed now a lot. So it was interesting. Yeah,
and you know, something that you said actually reminds me of something that I was told in my first semester of microbiology, because my professor at the time did some work on, like, you know, washing powder and things like that as well. And he mentioned washing powder. There's been so much research and development, especially with microbiology, in terms of all the enzymes that go into washing powder. And it was something that blew my mind. And I don't think it's something that people appreciate when they take it off the shelf. They're literally buying years and years of research and development work. So can you talk a little bit about that? Hopefully I'm not testing your memory too much.
You use amylases, you use protease to break down proteins. And basically for detergents, I mean, the pH is higher. So you have to select enzymes which can resist to that higher pH and to the higher temperatures. At that time, we used higher temperatures for washing. Later, they selected enzymes which also worked properly at lower temperatures, because now everybody washing at like 30 or 40 C. At that time, it was like 50 or 60 C. So that changed a lot. So I'm not aware of more enzymes in detergents. Right. I actually, that was the only enzyme I worked on for detergents. Later, I worked on all other kinds of products, enzyme, but also like small molecules, pharmaceuticals. So I worked on so many products. I even don't remember them all.
Yeah, that's crazy, and I hope we get to unpack more of
Yeah.
that as we go on.
Yeah.
John, did you just want to jump in with a question? Because I knew you were wanted to unmute a few times.
Yeah, that's true. Yeah, there's a few questions that I'd like to ask you. I mean, your stories are very interesting. It's very intriguing. Thank you for sharing about the processes. So basically, I am, checking your profile, and it says that you have been working for 25 years in a company. So what is it like working at that period of time within that one company?
Well, I actually, that was May 1st. I worked 25 years for that company. But like Wei said in the beginning, I worked there before, left and came back. So I have another career, an early career of 10 years. So in total, it's already 35 years at that company. And I worked 6 years in between at the biopharmaceutical company. Well, you're not going to mention the company, but I mean, it's a very big international company. The attractive thing of that is that, I mean, it's big. The R&D group is big. Like I work in Delft in the Netherlands, and there's about 400 people working in R&D. So if you, at one point, you say, okay, I saw it, I would like to change to another project, you just say, I would like to have another challenge, and they will look for something, and you move to another project. So there's a lot of variation. And also there are several production plants over the world, either for food or other types of product. So I'm involved on the interface between R&D and production. So I also visit several production plants in the world, like I visited the one in Sydney 3 years ago, but also like we have another plant in Germantown in the US. In the past, I have been involved in a project where I went to France or Germany or Italy. A few times I went to the Shanghai region. So that's the nice thing of working for a big company. You have a lot of opportunities.
Sounds like you traveled a lot. So
yeah.
what's it like traveling around here in places and exploring like different laboratory? Because I can assume that most countries would have different laboratory practice, or are they all uniform, or they're all the same?
Different manufacturing sites as well.
Yeah, manufacturing sites indeed. No, it's all different. For example, I have been involved in setting up a lab in Shanghai. And then I was making user requirement specifications for the lab and what space they needed, benches, equipment. And I said, okay, you need, for example, a washing machine to wash glassware, etc. And then they said, well, we have washing ladies. I said, washing ladies? Yeah, so I mean, it's kind of also for employment. So they hire washing ladies to wash your glassware. So it's like you have to weigh either a machine or hire a person or several persons to do that job. I said, yeah, but it also need to be washed very carefully. I mean, it could have an effect on your on the quality of your experiments if it's not washed in a reproducible way. And so in the end, I could convince them to buy a washing machine, obviously operated also by these washing ladies, and they did other jobs. So that is different. I mean, this is not a discussion you have in any other part of the world. I have been like in Australia or the US. You sometimes have to deal with different regulations. For example, I'm now talking more about production, like titrant in the US, like you have ammonia. They use 90% because that is the maximum concentration they transport over the road. Like at another place, you have to 25 or 27%. It's not an issue. So you have to deal with that kind of things. Different permits for chemicals. I have also been working on a project in Brazil. In Brazil, it's really a hell to work with chemicals. I mean, you have to register chemicals like in three different at three different authorities, like a municipality, like a central one for the country, also when it's involved. But I guess that is similar in several countries when it can also be used for like drug manufacturing. There's an extra registration. But there it took about a half year to set up everything, like the formalities. So that was very difficult. So yeah, I have seen different countries, different ways of working, different regulations, and well, I find that the interesting part of it. Learn about the cultures, and it's not always easy, but it's always interesting.
There. Thanks for sharing that.
Thanks for sharing. You
Those
can never stop learning.
insights. Huh? Yeah, that's
Never
just
stop
crazy,
learning.
Paul.
Yeah.
So if we go back to sort of specifically your career for a bit, so like you said, you know, you started working in the media makeup, and you know, I can assume later that you eventually quickly moved on into R&D work. So what was that sort of transition like, and how was that? I guess that was more in line with what you were interested in rather than being in the kitchen all day making media.
Yeah. So yeah, I mean, was really from day 1 to 2 working fermentation, like learning on the job. So I just teamed up with an experienced lab tech who taught me everything. And yeah, meanwhile, I was studying in the evening. In the end, I went 6 years to the evening school, and it was 3 evenings in the week, and then you still have your homework. So I would not recommend anybody to follow that path. Just continue studying until you're ready and do your traineeships, because I mean it's pretty intense this way. So I think I worked for about 1.5 year, 1 year already in fermentation when I got my first class of microbiology. So and then obviously I already knew about several techniques, but sometimes not. I didn't have the theoretical background to fully grasp everything I did. So yeah, that was interesting. But really, at the time, that was possible, that you just learn on the job. And yeah, basically, we did a kind of routine fermentation, so it's doable. And if you have a limited amount of projects, you can learn it also that way.
Was it mainly like pilot studies and then scale up sort of work? Is that what you were doing?
No, this was small scale, so maximum like 10 liter scale, 10, 20 liter. And
right.
The moment I got involved in pilot work, that was actually when I went to the other company. I started working in a pilot, and like biopharmaceutical manufacturing, which is smaller scale than we used to at the company I work for now, which is really industrial, tens of cubic meter or even hundreds of cubic meters.
Yeah, and then so you were saying, you know, so you worked in sort of dairy fermentation, dairy cultures, and then you transitioned into biopharmaceuticals, more in terms of the pharmaceutical side. What was that like? I mean, that must be, I think I know what you're going to say, but
yeah,
if you could tell us what was that like, and what did you work on when you transitioned into biopharmaceuticals?
Yeah, so it was interesting. It was a startup of European branch of an American company, and they built a pilot plant in Amsterdam, and it was like for registration of pharmaceuticals in Europe to do some trials and registration batches, and maybe later also new development of pharmaceuticals. So basically in the beginning it was E. coli processes. I worked on interleukin 2, beta interferon, and later also like subunit vaccines like meningococcus C, also bordetella pertussis, which is whooping cough, I think, a vaccine. So the interesting part was it was a new company, new building, new pilot plant. And when I arrived there, I mean, it was empty. We had to fill it. Some equipment was purchased, but still had to come. So so what we did is, well, we bought all the equipment, helped with installing, starting up, do all the testing and validation. Well, like I said, it was a pharmaceutical company, biopharmaceutical. So GMP, generate more paper. So you had to write a lot of procedures and follow them. There's no way to do R&D without carefully preparing that, describing.
That's the part you hate, right?
Exactly. So after some years, okay, it went from, let's say, development, it went to only production. And then I said, okay, for me, it was interesting, but it was enough. I prefer the R&D and development work, or in between production and R&D. Yeah.
Yeah.
So it's, I mean, it's interesting, interesting to learn the way of working and what is required for that. And interesting to see how biopharmaceuticals are made. And, it's impressive. Yeah.
So at what stage were you taking an interest in R&D?
Well, I after the 2 years work in the media kitchen, I started working in R&D. And then I worked there 8 years. And then I moved to that biopharmaceutical company. But that was basically transferring a process from the US to that pilot plant. And yeah, that took a few years until everything was running smoothly, validated. Then we had a few other proteins coming in and being produced. And at the moment that it switched, no, they were taken over by another company. There was some remodeling of the pilot plant, again, new equipment coming in and starting up and validating. And then they said, oh, we're gonna do only production. And that was the moment I thought, okay, that's enough for me. And then I went back to the company I worked for now again for 25 years. And I came back in an R&D function and also started working in pilot fermentations. And after some 5 to 10 years, maybe also working at production sites, so transferring processes, troubleshooting, yeah, diverse work in different types of projects. And only the last, what is it, 4 years, I work in cultures, so for dairy and cheese enzymes. Before that, I worked also like in bioethanol projects, so for the production of enzymes or the C5 yeast. Yeah, diverse type of projects.
Right. And do you have any advice for those who wants to work in R&D? Like, how do they get to R&D? Like, what do they need?
Yeah, advice. I mean, I don't have really a typical career. You have to start at a job, and I guess you have to have some, you need to be flexible, creative. To my opinion, also, when you see an opportunity, just take it or go for it. Express your opinion that you would like to do a type of work or that you want to move in a certain way. For example, at one moment they said, oh, we're going to set up something in China. I immediately said, oh, I'm interested in doing that. And do you have a project for me, or can I help somewhere? And then you if you're interested and motivated, they will see it, you get the opportunity if they think you can do it, obviously. So I think if you see opportunities, go for it, take it, and express your opinion, what you like, what you don't like. For example, I worked on project at one point, I was fed up with it. I said, I feel it's not good. I'm not so motivated anymore. I need to switch because it's not good for me. It's not good for the project. So I always did it. It was based on my feeling, and my interest in certain subjects. So that is how it was my career. So not really planned from the beginning, but more like looking for opportunities or grabbing them when I saw them.
Yeah.
Oh, that's awesome.
Yeah,
and also,
and
No,
also
go on.
I think I mean I worked for the company like 10 years, but at one moment I thought, okay, I work here 10 years. Am I going to stay here, or what am I going to do? So that was that point that I moved to that other company. I thought, okay, at that time I was about 30. I thought, okay, I think I want to move to another company and see what type of work they have there, learn something new. And it's really interesting. I mean, this is a big company. That biopharmaceuticals quite small, at least that branch here in the Netherlands, like 100, 150 people at one moment. And you learn different things. You don't learn in a big company. You have a more broad type of work. The ways of communication, the communication lines are much shorter. So it's also interesting to learn that. On the other hand, working for a big company, yeah, I mean, there are so much opportunities, different kinds of projects. We have all the worldwide locations with labs and production sites. You don't have that with smaller companies. But I like both for some period of time. So yeah, like said before, I like the variation. So when I see an opportunity or I feel like it's time for something new, I'm gonna talk about it. Or when I see something interesting, I grab the opportunity. So that's how I did it so far.
That's awesome. Paul, we only have time for one more question. So I've been dying to ask this.
Okay.
We won't go into any confidential territory, but as you sort of alluded to, you worked on many projects throughout your years. What's been the highlight so far? What was the project where you just, there was a problem to solve, you initiated the project, or even if you didn't initiate it, you executed this project and then you solved the problem and you thought, that's a bloody good job that I did.
Well, sometimes you have a big problem in either implementing a process on a production plant, or you have a scale-up problem. And I mean, it's different than if you have a failing lab experience. Okay, you're gonna think you do it again or another time, but like if you mess something up on production scale, it's like you lose like 20,000 euro or 50,000 euro or even more. So it's really rewarding if you quickly find the reason why something doesn't work out and it works out in the end. I mean, I recommended sometimes things which didn't work out. And if you, I mean, you have to learn from that too. And if you work on production sites, you have a tough talk then with a production manager with some colleagues. So you have to explain it. Yeah, okay, I overlooked this, or I didn't think about that, but I think it's about this. So you sometimes have some tough talks because it's quite some more responsibility. So for me, it's really rewarding if I solve the problem quickly, and then nobody cares anymore. That's one run did fail. I mean, it can happen, everybody knows, but everybody always plans for success and it has to go right first time. But yeah, it's not always working that way. So if it's working first time right, that is really rewarding, but it's more often that something goes wrong in the beginning and you quickly have to solve it.
Yeah. So basically what you're saying is you'd be bored if there were no problems.
Yeah, but some of them I would like to have not. But
don't have too much problems.
For example, that I had one time I decided, we called that the one-shot approach. I had 3 changes in the process one time, and it didn't work out well. Like we had a high viscosity, everything went wrong, and then you have to go back to analyze which one of the 3 didn't contribute to did contribute to that bad results, because we tested them all 3 separately and thought, okay, we do them all together.
Oh no,
but
yeah.
It didn't work out.
Yeah.
So then I had to go back.
Far out. That's crazy. I mean, Paul, we could talk for hours and hours about everything that you've done, but unfortunately we're out of time. So I'd like to thank you again for sharing your experiences with us, and maybe we have to get you back on the show again to
explain more,
talk some more. But yeah, really appreciate it. Thanks for your time today.
Thanks for joining the show.
Yeah, and thank you for having me, and good luck with SwitchHub.